Hi everyone, in this tutorial we will be digging a bit deeper into components and how they relate to our current CAD Dream tools. And we'll be doing this by looking at some custom cutters. We'll build some custom cutters and see how we can import them and apply them to some gemstones in an efficient manner. So in this file I have a basic setup of some gemstones around a round halo type shape that we will be applying some cutters on. I want to create a custom cutter that will perform a drill cut like our cylinder cutter, and at the same time I want it to perform a kind of scallop cut with square sides, so square side cut on each side here. And we don't have a tool that will perform both of these. Of course we could use a combination of tools. We could use our cylinder cutter and perhaps the scallop cutters. Maybe we could modify the sketch in there to get the straight sides. But I want to just explore using or creating our own custom cutters and how we can use them by exploiting our current setup of jewelry cutter tools. So let's create a new file, and I'll zoom through this build of the custom cutters since it's not really going to be the focus of the tutorial. And I'm just going to call it custom cutter round. Okay, so we'll be creating some variables for these cutters, and let's get started. I'm just going to bring in first of all a circle to denote the size of the gemstone that we'll be placing the cutters on. So let's place it on our global datum, align it to the top plane, and the diameter I'm going to insert an equation, and this will be the gemstone diameter. And let's start off at 1.5. Hit the green tick, apply, OK, and then we can assign it to this field expression, variable browser, gemstone diameter. Okay, we covered these variables in other classes. Right, so now I'm going to insert a cylinder, again center it. Let's align it for completeness, and I can see I've actually not aligned that circle, so I'll go back and properly align that. The radius I'm going to insert equation manager, and we'll call this cylinder, the radius, or I'll change that to diameter actually. I want this to be a ratio to the stone diameter. So I'm going to create a ratio cylinder to gemstone, gem ratio, and let's go for 0.8. That'll be 80% the size of the gemstone diameter. Whilst I'm here, let me add in a few more parameters. We'll call this cylinder depth. Let's go for 1, and cylinder height. We'll go for 1 again. Okay, now the radius, I want to change this to a diameter by toggling it here. And now I will create an expression which is going to be the gemstone diameter multiplied by our ratio. And that's going to scale according to the gemstone diameter. The height is going to be assigned to this length field. Confirm, I'm going to do a face offset, and this will be the depth. Okay, we can just left click in the field, left click the variable when you have the variable browser open. So I need to center this circle again. I'm just going to right click, redefine, and make sure this is centered. I need to unpick last and make sure it snaps there. Okay. Right, so I'm going to add a fillet to this end to round it off. Now the fillet, I want it to change according to the diameter of the cylinder, and for this I need to insert an expression, and this expression is going to be the gemstone diameter multiplied by the gem ratio. That's getting the diameter of the cylinder, but then I need to divide this by 2 to create the radius, to get the radius of the cylinder, and this will be the result. Okay, we get the perfect half sphere as the base of the cylinder. Now, it's fine, but geometrically speaking, it's fine. I do get a bit funny about these precise points of intersection. Well, it's not really intersecting here, but it's coming to be a finite point, and I really like to just modify this value. I'll increase it by a slight amount so that we have just a little face there, just so that we're not coming to an exact point. Again, it actually doesn't matter, this software handles it fine, but I just like to make sure of that. So that's our cylinder part. I'm going to blank this, insert a sketch, and I'm going to place it on the front. Now I want to create my square cuts on each side, and I want each side to have different parameters. So I'm going to create a rectangle, and we'll center it, just drag out an arbitrary distance, and then we'll assign some variables to these. So at the moment, when we change the width, scales nicely, and the height. Okay, but I want to be able to change the height above the pavilion and the depth below the pavilion separately. So I'm going to first of all highlight this dimension, delete it. Now we have a point to midpoint constraint here that causes it to scale in this fashion. If you'll see the point here, the midpoint is the global origin, but the 2 points are here and here. So the midpoint, when we change this value, it's going to make sure that this length is equal to this length, and we don't want that, so I'm going to left click on the constraint and hit delete. Okay, now we need to cause this to snap to the origin, and this will happen naturally when we insert a couple of lines here and here to help us dimension the top and the bottom. So I'm going to just toggle these to construction. We'll insert a dimension, another one, and let's see how everything is moving. Okay, so what we need to do is force these to be vertical. Constraint, vertical, just left click, you'll see the icon pop in there, and let's check again. Okay, so that's scaling how we want it to. That is as well. And okay, we're good. So now we can create some variables to assign to these dimensions. So I'm going to insert equation manager. Now we don't see our previous equations in here because we are inside of a sketch, but it's not an issue. You can still add them in here and access them from a sketch drop-down in the variable browser. So let's come in with another ratio. We want a ratio for this side to the gemstone diameter. So we'll do it this side 1, and I'm just going to copy that side 1. Side 1 to gem ratio, and let's say 0.5. Pasting in that side 1, and height, let's go for 1. Depth, let's go for 0.4, and I'll add in a length. Well, I'll add that in the part level. So okay, double click the dimension, link this up to the height, depth, and then this is the ratio, side gem ratio. It's quite hard to see what we're doing in this little box. Side gem ratio multiplied, and we navigate back to our gemstone diameter. Okay, exit. We're going to insert another sketch on the same datum plane. Same method, but with a side 2. So drag this out arbitrary distance. Let's just insert those equations now. And we'll call this side 2 to gem diameter. Let's go for a 0.6. Depth 0.4. Height 0.8. Apply, okay. Then we delete this dimension, delete that constraint, come in with 2 lines, or we could draw 2 at the same time. Just straight down, middle click, control picking, toggling them to construction. We need to constrain them to be vertical. And then we right click and dimension them. And this is the height. Again, I'm really zooming through this because it's not really the focus of this tutorial. We can create a component in any fashion we want. And then the important bit will be how we can apply it to our main build. Okay, and then we're going to do an extrude, but before that, let's insert two more variables, and this will be side 2 length, so 2, and side 1 length, 1.5. Now, I think this was the side 1. Our first one, yep, sketch 1, so let's extrude one side, and it's going to be, in this case, a negative value, so expression, negative side 1 length. Confirm, middle click, and we're extruding this sketch, and this is just going to be a positive number, so we can just pick it straight from our variable browser, side 2 length. Let's unblank all. We'll erase the curve. And finally, we just need to link these up to our driving parameters. Left click, right click, browse variables, and here we go. Let's do the cylinders in a bunch. And then the side 1 length, side 2 length, and this is where we have to pick our variables from the sketch drop down. Okay, and we could test this out. I'm kind of going to trust that it is working. Let's just test the scaling of everything with our gemstone diameter. And they all seem to be scaling nicely. Okay, so now we can save this. And this is just our custom cutter round. Okay, so we can create a whole bunch of different cutters and create our own component library in this manner. And then the way to implement them, in this case with a cutter, come into our file. And let me just demonstrate how our components, our tools work with components. So let's come in with a pilot cutter. And we'll just use the usual strategy. We pick our feature. And let's give it a 0 elevation. And other than that, we'll just use the default parameters and kind of cancel out the tweak. Okay, so we have our cutters, and they're placed on two different sizes of gemstones. I believe there's 1.25 and 1.5. And our cutters adapted to match the diameter of the stone. Now, we're not going to be able to recreate that dynamic matching of the cutter width to the gemstone width with our own custom cutters. It just won't work that way. But we can kind of cheat and effectively place our cutters instead of, in this case, the pilot cutter. And if we just move back into the root level, we can see how our components work. Okay, so we have our main assembly here, and then we have these other parts, and you may not really know what these are, but when you look at them, it starts to make sense. You see that you have your two gemstones. These are the 1.25 and 1.5 millimeter gemstones. Then we have our two cutters. And these are just the single instance of the cutter, and then of course it's just replicated elsewhere in the build. So we have this assembly built up of these four parts. This storage can be ignored. And everything is always stored. All of the parts that are brought into the main build are always stored in this root level. And you've seen me before in a previous tutorial show you how to tidy up our root level. If, for example, we start bringing in all of these other, let me just blank out this components. For example, if you decide you didn't like the pilot cutter and then you went to delete them, come in with a different cutter. Let's try the elliptical. Okay, so we brought in our elliptical cutters, and you can see that this extra component is added into the root level. If you then delete the operation, we find that the elliptical cutter part is still in our root level. Okay, and if we do this over and over again, trying different components, we'll get quite a large root of unused parts. And if you ever want to clear this out, my little trick is just to window pick every single part, including the ones you are using. Just make sure you don't include the assembly. Hit delete, so you have just the assembly left. Double click on the assembly, you'll see all of your components are gone, and then just regenerate the history, and it's going to regenerate only the parts that are used in the history operations. So now that this is regenerated, we have our pilot cutters back, but we don't have the elliptical cutters in the root level, so it tidies up our root in that way. Okay, so what we're going to do to insert our own custom cutters is basically edit one of the current cutters. So let's go into the history of this component. Okay, and I'm just going to add a simple block just so that we can see what we're doing, or see the effect that this has. So we've added this pointless block to the cutter, but then if we come back into our main assembly, we see that that block is replicated all around on our stones. So the strategy is we copy or overwrite our custom cutters over the top of these pilot cutters. So to do this, I'm going to come into my custom cutter, exit back into the root, highlight the part, right click, copy, come to my component, root, right click in this grey box. It won't work if you right click in the manager. Right click in this grey window and paste. You'll see the part copy into there. I'm going to rename this 1.25 millimeter. I'm going to copy, paste it again, and rename this 1.5 millimeter. And you'll see why in just a moment. So now we have our parts in this file. Let's just save. We're going to come into, this is the 1.25 millimeter cutter. We can check that by coming into our attributes part, driving parameters, gem length is 1.25. I'm just going to window pick everything and erase it. I'm then going to right click, insert component, pick our 1.25 millimeter cutter and drop it on the global origin there. The 000 axis. Now I wanted to show you something back there, so I'm just going to undo this. Insert component, pick the 1.25 millimeter again. Now typically when I insert components, I always want to copy the part, because this means that if I make any changes to the inserted component, it's not going to modify the original. But in this case, I do want to have that linkage between the original and my inserted component. And again, we'll see why in just a moment. So let's place that. No align needed, and that will do. Exit into the root. Let's come into our main assembly. Okay, we can see another assembly created here because we've inserted a component into a part. But if we come back in here, we can see that we have our custom cutters applied to our gemstones. Now, we need to make some tweaks. Okay, and to make the modifications, we use our variables, but we have to use the variables that we created in the original part. So let's say we want to, well, that gives us plenty of depth. Let's say we want to make this side wider, okay, which we would want to do. So perhaps, I forget, is this side 1 or side 2? Let's see, we come back into our root, come into our 1.25 millimeter, attributes, part, driving parameters. I believe that was side 1, so we're going to do the side 1 ratio to 0.75. Press OK. exit back into the root, come back into our main assembly. So there is some jumping around here, but you can see we now have this updated. Okay, and that might be suitable for our needs here. And I can do the same again for the 1.5mm. I come into the cutter that represents the 1.5mm. We can check it by doing attributes part driving parameters. It's the 1.5, that's what we want. We need to erase this shape. Right click, insert component, pick out 1.5, the location. Again, we don't want to check copy part. And if I just uncheck this align after insertion, it means that align window doesn't pop up afterwards. So there I've inserted the component, exit back into the root, and we come into our main assembly. And okay, we need to make some tweaks here. I forgot to modify, in both of them in fact, I forgot to modify the gem diameter, gem diameter of the cutter. So I'm going to exit into the root. First we'll start with the 1.5, attributes part, and in fact the gemstone diameter is already 1.5 for this, so it's fine. It's just the previous 1.25 that we need to modify. I'm going to increase my side 1 ratio again to let's go to 0.75 and see how it is. 1.25, I want to change the driving parameters, change the gemstone diameter. Okay, let's see how this looks in our main build. And I've increased the wrong side there. So what we could do is simply rotate the entire cutter in the original file itself, or we just tweak the opposite side larger. Either or. Let's just tweak the opposite side larger so that we can avoid that rotation. We're just going to essentially swap these values. Okay, because we want the outside cut to be larger than the inside cut. And, we may be happy with this. This may work. The only step left to do is to remove these cutters from our shape to cut out that material. So that brings up an interesting point, and that is if we are to just merge our, let me just hide the gemstone layer so I can window pick all of these components. If we merge all of these components and try to window pick shapes, we're seeing that they're not picking, they are still components. And the reason for this is that these are a component inserted with a component. So we actually need to merge twice. Merge them twice, and now they're shapes. Okay, the reason for that is that they are components or parts inserted as a component into our cutter, inserted as a component into our main build. So we had to merge them twice. Okay, let's bring back our gemstone layer. We'll do a face offset. Just add a bit of extra material above the gemstones. We'll do a quick face, an offset of the top surface. I just want to remove a bit more material. We'll just do a 0.1. Keep the original surface. We'll give it a different color, red, and then we'll shell these. Shell. Let's just go negative 0.4. Middle click. Do the same for this side. And then just a face offset. And you'll see why I'm doing this in just a moment. It's just the center cut there. Face offset here as well. And actually, that is a good amount, maybe a bit more. Okay, so we'll do a combine remove now. Combine remove. Window pick these shapes. Okay, I didn't pick them all. Let's redefine. There we go. This side as well. And then our center bars. Alright, and there you can see we have our custom cutters removing the material we want, and they have been inserted efficiently using kind of almost hacking our previous tools in a way there. But it's a nice little strategy there if you want to build up your whole an entire library of custom cutters and other custom components, then you can kind of manipulate the environment by using our previous tools in this way. The way CAD Dream is set up with these components and assemblies, it makes for a quite creative and expansive modeling experience. So I hope that was useful.